Hello, welcome back to Maison African Motives, still on electrotechnics and for working on the principles of electricity. That is working from the question paper of August 2021. We have a similar question that we just need to understand from some of the questions that we worked on our calculations. That is 1.2. If we check on 1.2, we are given the information in this case. That is, let me just have it aside here. A heater of 40 watts, which draws 2 amps, and a resistor of 20 ohms are connected in parallel. So take note that we have got a heater in this case. So definitely a heater is going to give us an element in this case, which you're going to take it as a resistor. We're just going to take the resistance of it. Then it is connected to a resistor of 20 ohms. These two, they are connected in parallel. So this is connected to a resistor of 20 ohms in this case, like this. All right, so these are connected in parallel. Then from there, a resistor of unknown value is connected in series with the parallel branch. So there is a resistor here which is connected in a series with the parallel branch. And so that is what you're given. Calculate the value of the unknown resistor if the circuit is connected across a DC supply of 32 volts in this case. So this is a DC supply of 32 volts. So we're going to have this connected to a DC supply. All right, so that's something like this. In this case, we are going to have our DC supply like this. All right, so as you can see, this is actually a similar question. So we're going to have our voltage here of 32 volts. So given this is 32 volts, this is the unknown resistor, the series one, and we are given. So remember, this is our heater in this case, which is our heating element. So here we have given the heater. So the resistance there of our heater, we can just say it's R1, which is, we do not know the resistor, but we're given the power and the current from the heater in this case. So from our heater, we are given the power of 40 watts and the current of 2 amps, meaning to say we can calculate the resistance from there. All right, then the second one, we have got its resistance here, which is 20 ohms. All right, so that is what we're given, and this will be the supply current. So that is it. So we are given this heater, it draws 2 amps. So this heater here, there's a current which is flowing across the heater of 2 amps. So what we do not know is the current that is going to flow across the second resistor. This one is going to be our R2 in this case. So we do not know its current. So the question is to calculate the value of the unknown resistor. We did a similar question like this, I remember. So how can we answer the question? It depends with the information that you're given. In this case, we can calculate, we can have the total current. Since if we can have the total current, it means this is the current that is going to flow across this Rx. And also we can manage to calculate the voltage across Rx in this case. Here we are going to have from our parallel circuit, we can also calculate the voltage across our parallel circuit in this case. All right. And also we know that the voltage across the heater is the same as the voltage across the reservoir. Since it's a parallel circuit, the voltage is the same. So you can take advantage of the power that we are given to calculate the voltage, because in parallel, the voltage is the same. All right, so let us take advantage of our heater in this case. So we can calculate VP in this case. So for the meantime, let us calculate VP for the parallel circuit. All right, for this parallel circuit, like I said, this heater has got power and current. So from power and current and voltage, remember the formula for power is given as voltage times current. So as we need the voltage in this case, this will be our parallel voltage. So divide by current both sides. So our voltage is going to be power over the current, which is the power in this case of 40 watts divided to the current of 2 amps. So this is going to give us a voltage of 20 volts, which is the voltage across the parallel combination here. So we are given a voltage of 20 volts, meaning to say also here we've got 20 volts across R2, because these two, they are in parallel. All right, so Having this, we can calculate the voltage across here. We can calculate VRX. So remember that these two voltages, they add up to 30 volts, which is the supply voltage in this case. So that means the total voltage, which is VRX, which is EX in this case, V can just say VT is equal to VP plus VRX, which is this one that we want. So remember, we need to calculate this one for the unknown resistor, the voltage there. All right, so let us substitute our values. VT is 32. For the parallel voltage, we took advantage of the power, so you obtained 20 volts there, plus VRX. So transpose 20 to the left-hand side is going to be a negative, so that means it's going to be 32 minus 20, which is equal to VRX. 32 minus 20, which is 12 volts in this case. So VRX is equal to 12 volts. So across this resistor, we have got 12 volts. So to calculate Rx, we are limited now to current. We need this current here. This current here is the same as the total current. So meaning to say, we need to calculate the total current in this case where we are limited. We need the current. So how can we calculate the total current? If from our Kirchhoff's laws, we can see that here we've got, this will be our current 1 and this will be our current 2. So the current flowing towards the junction, which is the total current, is equal to, so here we want to calculate the total current in this case. All right, so the total current, we are going to calculate it from I1 plus I2. So we're going to use I1 plus I2. These two flowing away from the junction is equal to the one flowing towards the junction. We have I1, we do not have I2. So where are we going to obtain I2 from? Remember, here we have got a voltage here and also the resistance. All right, we have got a voltage and we have got a resistance in this case. So we do not have the resistance so far. We do not have the resistance so far. So meaning to say, okay, the resistance is there, 20 ohms. Sorry, I don't know how am I checking this, guys. Okay, we have a voltage here. We have a resistance. So that means we can calculate I2. All right, so I2 is going to be taken from our parallel voltage, which is said is the same. So it is going to be the voltage in a parallel circuit divided by R2, which is the voltage for the parallel circuit, which is 20 volts divided to the current resistor R2. Our resistor R2 is 20 ohms. So 20 divided by 20, that's 1 amp. So we are going to obtain I2 as 1 amp. So here, there's a current flowing of 1 amp. So as you can see, the current flowing towards, which is the total current, is going to be the sum of these two. So our total current from our formula, we are going to substitute this here into our formula. That's our total current is going to be I1 plus I2. That's I1, which is our I1 is 2 amps from this one, is 2 amps plus I2, which is 1 amp. So that is, we are going to obtain 3 amps, 1 plus, which is 3 amps. So this is our total current, which is the same current flowing across here. So here it means there's a current flowing of 3 amps. So we can calculate Rx, which is our unknown resistor. Remember, our question is to calculate the value of the unknown resistor, which is Rx. In this case, we want to calculate Rx. So we've got current and voltage. So therefore, Rx can be calculated from the voltage across Rx divided to the total current, which is the voltage across Rx, which is 12 volts, divided to the total current across the circuit, which is 3 amps. So that will give us Rx, which is 4 ohms in this case. So remember, this is resistance measured in ohms. So it means here we have got a resistance of 4 ohms. So this is how we could have calculated the value of the unknown resistor. So sometimes, yes, they might give you this is a heater. This is what you need is the resistance there, whether it's a heating element, it's a fridge that is connected, whatever that is connected, take it as a resistor. Find have it as a normal circuit that you are used to. All right, then on 1.3, we are given temperature coefficient of resistance is defined as the increase All right, so this is the increase in unit resistance of a substance per unit rise in temperature from 0 degrees Celsius to the applied voltage, and inversely proportional to the resistance of the circuit. Now, the question is not about this definition, but to name two materials that have a positive temperature coefficient of resistance. So mostly here we're talking about metals. So metals, we are referring to metals such as iron. So we've got metals such as iron, such as silver, such as gold, such as aluminium, such as copper. So these ones would be actually having positive temperature. Then for the negative temperature coefficient, we'll be talking about non-metals. So non-metals, think of paper, think of plastic, plastic in this case, think of paper, think of glass. Also, something else, there's so many non-materials, non-metals like rubber also. We didn't list that one here, so you can also have rubber into these ones. So these ones, they have a negative temperature coefficient of resistance. All right, 1.4, we've got a circuit here that we're supposed to consider. An electrical network has got 2 or more voltage sources. All right, so, okay, but this one, it was 2, all right? So it's 2 or more, all right? As we've got 2. So this is the source. Apply the Kirchhoff's laws and determine the magnitude of the current flowing in each branch of the circuit in Fig 1 above. That is to calculate I1, to calculate I2, and to calculate I3 from this diagram. Apply from the Kirchhoff's laws. All right. How can we apply our Kirchhoff's laws in this case? All right, so let me try to reduce this diagram. I think we can see it clearly. So remember, from a Kirchhoff's laws, all you need is to find a branch that you're going to, a loop that you're going to work from. So here we're given the 2 loops. We've got this loop here, the second loop, also the third loop if you want to use it. So here I'm just going to use this first loop and second loop. They're enough to find these currents that we want. And also, according to the flow of current, remember from a Kirchhoff's law, this is positive. Our current is flowing this way, which is I1. This is I2. Together, they enter this branch, which is I3. So I3 is the combination of I1 plus I2. These two flowing towards the junction will be equal to the one flowing away from the junction at A. All right, so let me consider taking loop number 1. So in loop number 1, this loop here, remember the voltage, so which is our supply in this case, which is V1, is equal to the sum of the voltage drops. So we are going to add the voltage drops, which is current times resistance. So here, from this branch, we've got I1 and R1. These are, that's current and resistance that we have. If we move from this branch, AB, we have got I3 and R3 in this branch. So we are going to multiply I3, R3, that is plus I3, R3. But remember what I said, that I3 is taken as I1 plus I2. So I3 is simply equal to I1 plus I2. So instead of using it in our formula, we can reduce this by working with just 2 unknown values instead of having a lot of unknown values. All right, so let us substitute our values. Our V1 in this case, which is our voltage of 10. So that's 10 is equal to I1 R1. R1 is 10, so that's 10 times I1. So 10 I1 plus R3. R3 is 40 ohms, so that will be 40 into I3. But I3, I said this is equal to I1 plus I2. So you're going to substitute I1 plus I2. All right, expand your brackets so that you can collect like terms. This will be a plus here. 40 times I1, we are going to obtain 40 I1 plus 40 times I2, which is going to give us 40 I2. Collect your like terms. In this case, we've got I1 and I1 here, 40 plus 10 plus 40 in this case, which is going to give us 50 I1 plus 40 I2. All right, so you can even start by writing this side with the unknown values in this case. So this is your first equation, 50 I1 plus 40 I2 is equal to 10. This is your equation, guys. You can play around the equation the way that you want. You can even reduce this equation. You can see that 10 is common throughout. You can even reduce your equation the way that you want, because you are the one who is solving this, guys. So this is going to give us 5i1 plus 10 into 40. You're going to have 4i2, which is equal to 10, and 10 cancels. This is a 1. So this is our first equation, 5i1 plus 4i2, which is equal to 1. All right, so we're going to take this as our first equation. Let me present it this way so that you can understand. So like I said, this is going to be our first equation. All right, I'm just going to leave it this way. We do not know what's going to happen next. All right, so let us put this way. This time, let us consider this loop now, working with the loop 2 in this case. So if we are to consider the loop 2 in this case, this is what you're going to have from loop number 2. We have got the voltage in this case, which is the supply. It's a V2 in this case. This time we are working with the V2. So V2 is our supply. So we are going to have this as a V2 is equal to the sum of the voltage drop working this direction. So this is going to be I2 times R2. So we are going to have I2 times R2 plus here I3 times R3. So we are going to have I3 R3. As you can see, this one is a repetition. We had this calculated before, I3 R3. If you check here, this was our I3 R3 here, I3 R3, which ended up at 40I1 plus 40I2 here. This is where we ended up with our I3 R3. So you can just take it direct, I3 R3. This one, we are going to substitute this one. All right. So, okay, let us see. Let us see what we have. So we have got our V2, which is 20 volts here, V2. That will be 20 volts, our supply from that loop, 20 volts. So 20 is equal to I2 R2. R2 being 20 ohms. So it's 20 times I2 in this case. So we are going to have 20 I2 plus I3 R3, which is the one. Yes, you can substitute 40 into this. We are going to repeat the same stages that we did here. If we check, so you just substitute this part, 40 I1 plus 40 I2. This is what you got. So we are going to substitute as that part, the one that we got, which is 40 I1. All right, let me just put it here. So this is going to be 40 I1 plus 40 I2. All right, collect like terms, just like the previous part. We've got I1, 40 I1. We can add 20 I2 and 40 I2. That is the 20 plus 40, which is going to give us 60 I2. So like I said, guys, this is an equation that is in your hands. You can play around whatever way that you want. You can even reduce this equation. As you can see here, 20 is purely common throughout. So we can divide by 20 just to reduce our values than to work with bigger values. Yes, you can work with the bigger values, which is fine, but you can take advantage of this reduced here. We are going to have 2I1 plus 20 into 60, which is 3I2, which is equal to 20 into 20. This will be 1. So this is the second equation that you're obtaining from the second loop. So this is enough. Yes, you can choose to work with the third loop in this case, which is up to you. You could have worked with the outer loop, this one, the outer one, meaning to say you're going to work with the voltages, but it was going to be a lot, but these are enough. So with these equations that we have, we can calculate according to this part. We need to calculate I1 and I2 and I3. Okay, so let us take the first equation that we're given. This is our first equation. So we're going to take our first equation into consideration. So we obtained our first equation, 5I1 plus 4I2, which is equal to 1. This is the reduced equation that we have. That is our I1 first equation. Then the second equation here, we obtained 2. That is 2I1. Okay, I don't know how I write this 2. So this is 2I1 plus 3I2, which is equal to 1. So to calculate I1, which is our first current in this case, we can use whatever method that you want. You can choose substitution. You can choose elimination. Once you've got these equations, the way that you solve is in your hands. All right. So to find I1, let's say I'm using elimination. In this case, I'm going to choose to use elimination method. Elimination, I'm going to eliminate. All right. So to eliminate I2, that means I'm going to find I1. The moment I eliminate, to eliminate is to remove. The moment I remove I2, I will calculate I1. So how can I remove I2? I just interchange these values. I multiply on top by 3, down, I multiply. I just interchange these values that I'm having. So here we are going to multiply on top everything by 3, down, we are going to multiply by 4, each and every term. This is multiplying each and every term. 3 multiplies everything on the top equation there. So we are going to have 3 times 15, 3 times 5, which is 15 I1, 3 times 4, which is plus 12 I2, is equal to 3 times 1, which is a 3. The same 4 multiplies everything in this equation. So it's 4 times 2, which is 8 I1, 4 times 3, which is going to give us 12 I2, which is equal to 4 times 1, which is a 4. The moment you've got this, you can check that I2 is the same. We've got 12 I2, 12 I2. So we can eliminate I2 by subtracting. This is our equation 1, equation 2. So if we subtract, we are going to have 15 I1 minus 8. 15 minus 8, which is 7 I1. So that's 7 I1. Here we have eliminated 12 minus 12, that's a 0. So meaning this is no longer there. So we are going to remain with the 3 minus 4. The sign that you are having here is the sign that you use throughout. So that's 3 minus 4, which is minus 1. Divide by 7, so that we can calculate our I1 in this case. So as we can see, I1 is going to be a negative. So I1 as a decimal, that is going to be negative 0.143 amps. So this is negative 0.143 amps. That is our I1 in this case. All right. So to find I2, we can now substitute depending with what you want. You can even eliminate, you can even come back to this equation, eliminate I1. That means you can calculate I2, or you can just substitute into the equation this time. So this is to calculate 1.42. We want to calculate I2 in this case. So to find I2, you can choose these two equations. Which one do you want to substitute? So in this case, I'm going to choose equation 1. So from equation 1, so from equation 1, I have got 5 I1 plus 4 I2, which is equal to 1. And I obtained I1 before. So I'm going to substitute 5 times I1, which is negative 0.143 amps, plus 4 I2, which is equal to 1. These are now your mathematical calculations that you're dealing with now. So here we can multiply these two. That is going to give us negative 0.715 plus 4 I2, which is equal to 1. Transpose this to the right-hand side, so it's going to be a positive on this side. So we are going to obtain this as a positive. So that means 4 I2 is going to be 1 plus this, which is 1.715. Divide by 4 both sides so that we can obtain I2. That means I2 is going to give us a decimal in this case, which is 0.42875, which is to 3 decimal places is going to be 0.429 amps. All right, so this is our I2 in this case. Then 1.43, it was to calculate I3. That is I3 in this case. So I3, like I said, from this equation that we formulated before, where we formulated here, I said I3 is the sum of these two, I1 and I2. From this part, I3 is the sum of I1 and I2. So we are going to calculate from the sum of these two. All right, so that means we are going to obtain our I3. All right, so let us just have it here. We can just have it here aside with the here. So we are going to have 1.43. So I3, like I said, is the sum of I1 and I2. So we are going to add I1. Remember, it was a negative. So we are going to substitute that negative 0.143. So we are going to have negative 0,143 in this case. All right. That's negative 0,143 plus I2 in this case, I2. From these calculations that we made here, we calculated our I2 here. We got that's 0,429 amps. All right, so if we add everything, therefore, we are going to have the total resistance for R3, which is going to be 0,286 amps. All right, so in this case, we have calculated everything that was needed on 1.4, that is 1.41, 1.42, and 1.43, that is current 1, current 2, and current 3. So these are some of the typical questions that you might be given. Sometimes they might not even give you a diagram like this. They will just give you information that you need to place in the diagram, play around with the information that you're given, formulate a diagram, whatever diagram that you have formulated, then you can calculate your currents depending with the way that you understand. But that's it, guys. That's what we had on Electrotechnics N4, working on principles of electricity. That is from Mason African Motives. Till we meet again.